Sathyabama Institute of Science and Technology.
Good morning. For today's session, right, we are going to speak something about your specification based testing. In the previous session, we are saying something about equivalence class. For today's, we will be seeing something about boundary value analysis. Your specification based testing is a black box testing, as you all know. What is the specification? The requirements that is going to be provided by the customer to a developer or to an organization to develop the product. Those things we call it as specification. From those specification, we are going to test all the specifications whether it is going to be correct or not. The testing that is going to be done is going to be a black box testing. In this specification based testing, it is independent of implementation, as I already told, right? It never worries about whatever the language you are going to implement it. It is going to test whether all the requirements that are given by the customer are going to be present in your software, whether they are working properly or not. That's it. Suppose if the customer is providing you 5 requirements, all the 5 requirements must be working properly. We are going to check only the 5 requirements, how it is working. For that purpose only, we go for the specification testing. That is requirement based testing. The requirements given by the customer are going to be tested. It focuses on the functional testing. It is a behavioral testing, and it's also input and corresponding output. If I provide an input and it's going to provide a corresponding output, it is going to be a black box testing. That specification based testing is a black box testing. We are going to test whether the functionalities or the requirements that are provided by the customer are working or not. We are going to test those things. For testing those test cases, we are going to have a specification based testing as a boundary value analysis. Why do you want this boundary value analysis? What is the difference between the equivalence class partition and the boundary value analysis? A equivalence class partition is something, right, which is going to group the test cases or provide the inputs in a specific groups. Each and every groups we are going to partition, and we are going to test within the equivalence class partition. The boundary value analysis, how we are going to give the input for the test cases. Test cases is how we are going to test all the requirements in the boundary value analysis. It focuses on the boundary of the input space of the identified test cases. Rather than giving a value within the actual input that is going to be provided, we are going to concentrate on the boundary of your inputs for the test cases. So that's why we call it as a boundary value analysis. For example, a loop counters off by 1. That is inputs of the boundary of a range. If it is going to be off by 1, then we are going to test with respect to the boundaries. Inputs are the boundary of the ranges, 10 within 10 to 100. And the range that is going to be provided between 10 to 100, how we are going to give the test cases. If the test cases that is going to provide the input for the test cases, it is going to be based on the boundary value analysis, which you are going to look for today's class. Based on the boundaries, we are going to provide the inputs. The idea of the boundary value analysis is to provide input variable values at their minimum. For example, if a loop is going to be 0 to 100, 0 is the minimum value, 100 is the maximum value. Suppose instead of using 100, right, let me use an n, 0 to n. Their minimum value is going to be 0. I have to concentrate on the minimum value. Just above the minimum value, on one value above the minimum, that is 0 plus 1. The next value has to be considered the boundary value analysis. A nominal value between 0 to n. Within the 0 and n, I have to consider one value. And just below the maximum, the maximum is going to be n, so n minus 1 we have to consider. And at their maximum is nothing but at the maximum, that is n is going to be. So with respect to these, I have to group the inputs that is going to be provided for my test cases. The boundary value analysis works only on the boundary of your looping structures or repetitive statement that is going to be provided. An example that is provided over here, program takes 2 inputs, x1 and x2. And x1 is less than a and less than b. x1 is between a and b. And x2 is between c and d. Between c and d, that is a and b, that is we use an equal to, and c and equal to, that between c and either a or b. The second value can be either c or d. So we have the intervals. What are the intervals? A and b is for x1 and c and d for x2. How we are going to provide the input for the boundary value analysis? A BVA test case is function for 2 variables, single fault assumption. As I already told, right, one value if it is going to be minimum, for example, I am taking this C as a minimum, C and A, which is going to be the minimum. One value going to be the minimum value, another value is going to be 1 minimum plus 1, and another value is going to be maximum and maximum minus 1, and one value between this minimum and maximum, that's going to be the natural value. Similar way, in a generalized BVA, the two ways of inputs can be provided. One for the numbers of input variables, how the numbers are going to be provided, and what is going to be the range of input that is going to be provided for my inputs. The variable generalization, how we are going to generalize the varialization. Hold one of the normal value and let the other variable assume minimum, minimum plus 1, normal value, maximum minus 1, and maximum. So, the total number of test cases that is going to be provided for here is 4n plus 1 test cases for the BVA, for the generalization. Here in this BVA also, we have weak normal, strong normal, and robust normal. All sort of classification is also present. So, what we have divided, it's a boundary value analysis. We are going to assume the variables as minimum, minimum plus 1, normal, nominal value, maximum minus 1, and max. The total number of test cases that is going to present is about your 4n plus 1 test cases. The total number of test cases for a BVA, boundary value analysis, we have 4n plus 1. Second one, the robust BVA, the total number of test cases is going to be 6n plus 1. That is, it's going to have another 2 more characters we are going to add. The worst case of the BVA, total number of test cases 5 to the power n. And your robust worst case BVA is going to be 7 to the power n. That is, way that we are going to test on the boundary value analysis, right? We are going to increase the number of test cases by increasing the number of values. For a normal boundary value, 4n plus 1 is minimum, minimum plus 1, nominal value, maximum minus 1, and maximum. It is going to be the normal test case of a boundary value analysis. The BVA limitation, the BVA works well when the program to be tested in the function of the several independent variables that represent the bounded physical quantities. If the values are going to be quantitatively defined, then my BVA will be working perfectly. No considerations to the functionalities or semantic meaning of the variables. The variables, if it is going to be dynamic, right, then this BVA, we have to concentrate on the BVA testing. The worst case analysis. The worst case analysis, right, we have the values. We have the value that is 6n plus 1. It is going to have the boundary value analysis along with the actual values. It is going to test along with the boundary values. On all the boundaries, it is going to be tested. All the values has to be taken for the test cases with respect to the boundary values. It's about going to the worst case analysis. A robust worst case, as we have a robust in your equivalence classes, apart from the actual value and apart from the minimum value, maximum value, and nominal value, we are going to consider about the minimum minus 1 and maximum plus 1. Maximum plus 1. What is the minimum minus 1? For example, right, the loop is going to be 0 to n. How I will be testing, right? The actual BVA, it will be testing about 0, 0 plus 1, n, n minus 1. It is a normal BVA. The worst case BVA, right? It is going to be minimum minus 1. That is, the minimum value is 0, right? I will also test for minus 1. And I will also test for maximum plus 1. It is the worst case, robust worst case. So, if you think about, if I want to work about only the normal BVA, I will be giving the actual input and what output that I want. If my function must not work for the out of the box, if it not going to work, it must not work. If I decide right, then I will be going for the worst case BVA, giving all sort of values out of the box and try to test it over there. So, it is about your robust worst case. Your special value test, BVA is a special value testing practiced from functional testings. That is how we are going to provide the input. I want the idea behind the testing, right? We want to break the software. A tester tries to break the software by giving the inputs in such a way with respect to the perception that we want to break the software. So, a BVA is a thing which provides or identifies, help him to identify what all the ways it is going to work and also what all the ways it must not work will also be identified the boundary value analysis. It's most intuitive and least uniform. Use of test engineers' domain knowledge, gut feel ad hoc testing can also be done over here. Yeah, edge testing, it's also a part of a BVA. The edge testing is nothing but giving only the actual values and trying to test, not the end values, only the actual values and trying to test. We call it as a edge level testing. The idea behind it is a hybrid BVA, but it is more or less going to be weak testing, weak BVA. It never worries about the boundary classes. It will be giving only the actual values of the internal classes. We have what they are saying, right? If one case is testing is working, and if they also decide the other test case will work. Thank you.